Alright, so now that we're dealing with three-dimensional problems as previously stated, we're going to start dealing with vectors. And vectors are very useful in its geometric properties, and their simple geometric properties are widely used in engineering and math and science. And to begin with, we're going to start with the traditional definition. So vectors are simply an arrow, basically, a magnitude with a magnitude and a direction. So I'll draw a vector real quick. So you have a vector going this way, and then it has some, let's define our coordinate system as this. Oops. So we have y going this way, x going this way, and we could define our orientation in this following manner. So that's theta. It tells you a direction relative to an axis, and it gives you a magnitude, which is the length of this vector. And we're going to call this vector r. So that is a very basic definition of a vector. It has a position, which is defined by this angle, and it has a magnitude, which is defined by how long this arrow is. So we're going to start defining notations for this new concept. Not really new concept. I'm pretty sure you guys understand what vectors are already. So we're going to have some notations. One that you'll see in textbooks is that it's really bold. And, that is one notation for a vector. However, that's not really useful when you come to pen and paper, because now you have to like scribble until you get a dark, bold letter. So another way, a very traditional way, which I wrote here, you could have a with an arrow on top of it. So that is the most traditional way, I think. And there's also another way. This is only specific to unit vectors, but you have a caret on top of the vector. So this is only used for unit vectors, and we'll get to unit vectors in the next video. So, and then the last one, which I learned recently, is that you take a and then you put a little squiggle at the bottom of it. I don't know how to spell squiggle. I think I'll tell you to spell squiggle. Or is it a tilde sign? I don't know. But you put it underneath the letter, and that signifies it's a vector. It's a thing you'll see in dynamics mostly. So those are the different notations, and a very simple definition. We're gonna define what a scalar is. So a scalar. Let me get another color. We'll just choose black or something like that. So a scalar is just a quantitative value. So quantitative. I can't spell. Quantitative. I think that's how you spell it. Quantitative value. So it's just a number. It's a number, or in this case, in terms of a vector, it's the magnitude of the vector. So that is that. Now you might be saying, okay, well, I understand the difference a little bit. The one that just breaks down the definition even further is the idea of speed and velocity. So speed simply is the total distance divided by total time. And then velocity is the change in displacement over the change in time, or change in total time. I realize these are only average velocities, obviously, or average speed and average velocity. So the reason why this is different is that this value only gives you a number. It doesn't give you which way a vehicle or maybe a particle is speeding up, or how it's doing it, so to speak, if it's decreasing or increasing or so forth. But velocity gives you that extra ability, because now you can define a speed as negative or positive, and you also could define it with an orientation, with such as this angle theta. So that is the major major difference between these two ideas. So this gives you a quantitative value. This gives you an actual position, definition, and orientation. This comes with a full package, and that moves to the next topic that I want to talk about is the geometric properties of vectors. So vectors are, by basic definition, this idea of magnitude and direction, but they also come with the ability to manipulate, the geometry in 3 dimensions. And the main ideas that I'm talking about is the idea of the cross product. So the cross product is a very geometric thing that you can do to vectors. I'm going to just simply define it here real quick. We'll talk about it later. Parallelogram. And then we have the dot product, which is very useful. It's the projections of vectors. Projections of vectors. Alright. We'll explain these concepts in the future. Well, actually, quite in the very near future. So, the cross product gives you the area of a parallelogram. The dot product describes the projections of vectors. And these are like the only things you can do to vectors besides adding and subtracting them. And you can use these properties to solve geometric problems that can simplify a lot of problems, because now you could stop using calculation and start using geometry, and makes the problem a lot simpler. So that is the very useful thing about vectors. They have a very they have a lot of geometric properties. It's more than just magnitude and direction. It's the idea of geometry. All right. So we'll explore the geometry of vectors in the future, and that's it for this video, I think. The next topic we'll discuss are unit vectors.